Thank you. Thank you so much for putting this on. Huge thanks to NEB for creating this event. And it's so exciting to see all of you here to talk about this issue of waste in labs. So I have the honor of kicking it off, which means I get to talk about the easy stuff, kind of setting the stage on waste. And as I was putting this talk together, I was thinking about the word waste itself, because it's a word we throw around a lot. And I thought, what is actually the original meaning of the word waste? So I looked it up, and it turns out the origin comes from a Proto-Indo-European, that's a hard word to say, Proto-Indo-European word that means to abandon, to leave behind, which I think is really interesting, because when we think about waste, we're often thinking about it from the perspective of our perspective, right? Saying we don't want this anymore. But what if we were to think about it from the perspective of the object, which is actually what the word is intended to mean, about abandoning that thing? I think that perspective and that lens is actually really useful as we go through this talk and maybe thinking about the rest of the day, how we think about what we want to discard from the lab. Okay, so with that little etymology lesson, let's get started. So I'm with a nonprofit, as Nicole said, called My Green Lab, and our mission is to build a culture of sustainability through science. So we're really focused on changing the culture of scientific research to be more mindful of sustainability. And there's a really good reason for that. So I assume most of the people in this room are familiar with the statistics about laboratory consumption, but just in case you're not, I want to make sure we're all on the same page here. So laboratories are thought to discard about 12 billion pounds of plastic every year. That's a lot of plastic, a lot, and that's worldwide. If you think of an area 23 times the size of Manhattan, which is also roughly about 23 times the size of San Francisco, ankle deep in plastic, that's what we get rid of every year into landfill. That is a lot. That's why we're here today. It's a lot. That's just the plastic. If you look at energy consumption, laboratory spaces consume 5 to 10 times more energy than office spaces and 4 to 10 times more water. So not good, right? And what's crazy is I say these statistics on a regular basis, and that is still my reaction every time I look at them. Because the thing is, it doesn't actually have to be this way. It would be one thing if this is what was just required of us as scientists in order to do our work. We just had to use this crazy amount of resources. Well, okay, we could have a conversation about that if that were true. But it's just not true. And the reality is that we use so many resources because that's the way labs have operated for the last 30, 40, 50 years. And we're just continuing to operate them in the same way as the people who came before us. Not that it's our fault, it's just that's how we're trained and that's what we do. So we have a huge opportunity here to do something about this, which is amazing. Now, I also want to give you a bit of context on where you all sit relative to the larger worldwide community or the national community of laboratories. It may surprise you to know that there are a lot of labs in the United States, about 250,000 labs that are just in life science research. If you also include industrial lab spaces, if you include other types of laboratory spaces, you're talking over 300,000 laboratories in the US. So you are part of a very large community. If you look at the entire industry as a whole, which includes not only all of you who are working in labs, but everybody who's supporting you, all the companies, all of the environmental health and safety, the facility staff, you're now talking about an industry that is almost half the size of the automotive industry. Think about how much attention has been paid to the automotive industry when it comes to sustainability, and think about how much attention has been paid to our industry in terms of sustainability. Together, we can completely transform some of the largest companies and some of the largest industries on this planet. So that is what I want to give to you, to empower you to understand that your voice is really, really important in this. Okay, so what can you do? Well, there's a lot, and I'm just going to focus on one thing related to what we're talking about today, which is A lot of the consumption that comes from laboratories comes from what we purchase, which makes a lot of sense. In fact, a lot of the consumption and a lot of the waste and things that we discard in our daily lives comes from what we purchase. So if you think about something that you can do to reduce that, the best thing you can do is to purchase with awareness and intent. So what does that actually mean in practice? Well, as I said earlier, we were going to think about waste from the perspective of the object here. So let's start with, let's try not abandoning things in the first place, which is otherwise known as reduce in the 3R scheme. So if we don't want to have something to abandon in the first place, we don't want to bring the material into our space. So how do we do that? How do we minimize the amount of material that's coming into the lab? Well, there are a lot of opportunities for this. I'm just going to give you a few. So one, reduce packaging. There are opportunities to purchase conical tubes that look like this or that look like this, right? In one case, you have a piece of styrofoam that you are surely going to abandon. And in another case, you don't. So this is a super simple thing that you can do. And not just obviously on conical tubes, but in every type of product that you are considering for your space. What is it packaged in? Are you going to have something that's going to remain an orphan at the end of unpackaging that material or that product? You can also choose more sustainable packaging. So this is something that was released just earlier. Oh, I guess it was last year at this time. This is a paper cooler that was launched by Thermo Fisher Scientific, and now several other companies have come out with paper coolers or recyclable coolers in place of EPS coolers, which are, I think, the bane of every scientist's existence, right? So choosing something that's packaged more sustainably, even if it's from a different company that you maybe don't normally purchase from, versus choosing something that you know is going to be orphaned at the end of the day for you because you have no use for that material. So those are pretty obvious. Here is where things get a little bit more subtle. So dematerialization is kind of the term that describes what happens when you're using less material for the same product. So here's an example. Anybody here who works in cell culture will be familiar with this. This is a filtration system used to filter media. We used to use these all the time. If you've used these before, you know the top part unscrews and you throw it away. The end. Somebody came up with the idea of what if we were to just keep the bottom part and make the top part be that original bottle of media. And now you just put it upside down and filter it directly. And now there's no more top. That's an example of dematerialization. If you talk to some of the companies here, and if you kind of start talking to your vendors and suppliers, you might learn that some of them have done things like reduce the amount of plastic in the products that they're selling to you. That's another example of dematerialization. So trying to find companies that have gone through this process and products that are like this is a great way to reduce the amount of plastic that you're discarding. And then also products that are simply designed to reduce waste. So this is, again, a really simple one, and I'm hoping, fingers crossed, everybody here is already using this. So if you have pipette tips and you're using pipette tips, use, oh, did it go? Oh, it didn't go. Well, luckily there's an example right back there because I'm not sure why that animation didn't work. It's here. Well, anyway, reload systems. So instead of using pipette tip boxes, use reload systems instead. That's another great example of a product that's designed to reduce waste from the outset. Obviously, glassware. So I think there are certain applications where, as scientists, we all know glassware is a great viable thing to use. Examples are shown here. For example, if you're growing up bacteria, that's always done in glassware. We don't think twice about the fact that that's done in glassware. And yet, when you move to cell culture, again, not to pick on cell culture, but there's a lot of plastic waste that comes from cell culture. For some reason, we go back to plastic. So there's a lab actually in Galway in Ireland that switched over entirely to glass in their cell culture, which was just amazing. So considering glassware, I understand it's not always something that you can do, but recognize that it is actually an option. They're a center for neuroscience research. And so it's not just a little small lab, they're a lab that has 50 people. And they switched entirely over to glassware. It's a thing that you can do. Another thing with glassware is something that I like to bring to people's attention is sometimes you can use glassware for applications that you were using plastic but just didn't think about. And one that I love to bring up are those kits for isolating RNA and DNA. If you use those, a lot of times what they'll do is they'll show you to put the column inside of a 50 mil conical tube to run through all the washes. And so what happens is most people have 50 mil conical tubes with their columns set up to run all the washes, and then all those tubes get thrown into the trash. You can easily set those up in a glass cylinder. This doesn't need to be set up in a 50 mil conical tube. So thinking through things like that, where you can use glassware in a creative way instead of using plasticware. Another really great way to reduce the amount of things that you're discarding, particularly hazardous waste, and again, I know that this is not plastic, but I do think it's really important to mention, is to choose safer, more benign chemicals and reagents, because that is another huge stream, bless you, that comes out of laboratories. And oftentimes, again, what we're choosing to use in our experiments is just the result of what somebody before us told us would work, which is totally understandable. But now that we're in an era where we can be more aware with what we're purchasing and what we're doing, maybe thinking through, is there an opportunity to employ green chemistry in your experiments would be a great way to also reduce the amount of waste that's coming into the lab. Okay, so now we've talked about things that you can do to not have products that have to be abandoned. Let's say you have to bring the material in the lab. Well, then what's the next best thing to do so that it's not abandoned? Use it, right? So reuse. What are the opportunities for reuse? And again, these are going to be pretty straightforward. Like I said, I have the easy job where these are all the very simple kind of concepts. Serological pipettes. I often don't see people reuse these, but a lot of times when you use them, you're about to sterilize the thing that you're using them in anyway. So if you're going through a process where you're about to sterilize something, you don't necessarily need to be using sterile serological pipettes the entire way through. It's a really simple way to reuse something like that. And I don't often see people do that. I'm going to bring up these coolers because if you haven't looked for an outlet for these to reuse, there are occasionally people who will take them. Now, if you've already looked for an outlet and you have somebody taking some of them, chances are you're probably maxed out because it's not like there's a huge market for them. But veterinary clinics will sometimes take these and the gel packs if you have any ice packs, things like that. That's an opportunity for those. Sometimes there are local biotech companies that are starting up. Here's a great place to be if you want to find a local startup that also needs to ship things. So sometimes they'll take them from you. Trying to find places like that. There's also a Waste to Waves company, I think that's still in the Bay Area, that takes these and makes them into surfboards. So there are opportunities for styrofoam. Not large opportunities, so it's still best to not get it in the first place. But if you have it, try to find a way to reuse it. Interesting. Well, I'm going to blame it on the Mac because I don't have a fancy computer like this. So I'll just tell you what the third picture looks like because it's not showing up. And that is solvents. So back again to chemistry. There's a huge opportunity that I think is missed in recycling and reusing solvents. A lot of labs use things like acetone, acetonitrile, a lot of these other solvents, and they just think, oh, well, I'm just going to use this and put it in the waste container in the hood, and that'll be that, without realizing that everybody on the floor is doing the same thing, or everybody in the building is doing the same thing, and that you could easily get a solvent recycling system which would cut down on the cost of all of those materials, reduce the amount of bottles that are coming into the space, and allow you to reuse all of those materials over and over again. So if you are using solvents, talk to your neighbors and see if there's a way for you to start recycling and reusing those. Apologies that that didn't show up. I think this is a sign that my computer might be getting old. But see, I don't want to abandon it, so I'm just going to keep using it and just talk through what the pictures are here. And then finally, last case, right? If we think about something wanting to have a useful life, then it needs to have a useful life. What's the next thing that we do? Well, now we talk about recycling. So I really want to make it clear that I think people initially jump to recycling when we talk about what to do with laboratory plastics, but that is the last thing we should be talking about when it comes to laboratory plastics. And we'll, I think, discuss this more as the night goes on. But that is the last option, that reducing and reusing are way better options than this last one. So here, lots of material can be recycled. Laboratory plastics, some of them can be recycled. Nitrile gloves, which I feel like we are so lucky that Lisa is here because she's going to be talking to this point later on. There are some companies that will recycle their gloves, including Kimberly-Clark, TerraCycle, and Medline. Corning will take back all of their packaging and recycle it. So if you're not taking advantage of that program, you should absolutely be taking advantage of it. It's free. Millipore-Sigma will recycle their MilliQ water filters. Obviously, e-waste is something that should be recycled. And also lab equipment. This one often gets left off the list, but a lot of companies will take back equipment now and recycle it. So this is obviously not an exhaustive list. There are many things in the lab that can be recycled, but this is where the last thing we want to end up. Okay, now let's imagine you're doing all these things. You're sitting here going, okay, Allison, well, I do all of this already. Now what am I supposed to do? And I said, well, you need to purchase with awareness and intention. So what do you do now if you've already done all of this? That's a good question. Two pieces of advice. One, talk to your sales reps and your suppliers. I cannot emphasize this enough about what it is that you want to see in the lab. So that paper cooler that I showed you that Thermo launched last year, it might surprise you to know they had that for 10 years. 10 years, but they never released it. And they'll tell you this. I'm not telling you something that's a secret. Why didn't they release it? Why did they keep shipping things in EPS coolers? Because nobody complained. Nobody said to them, I really hate that you ship me an EPS cooler. It wasn't until their customers called them up and said, you know what, we would buy more of your antibodies if you would stop sending them in EPS coolers, that they finally said, oh yeah, we've got this paper cooler. The patent's been sitting around for 10 years. I guess we'll start shipping them in this instead. That's literally how it happened. And I can tell you countless stories like this of where things have started to move in laboratory sustainability, and they've only moved because you all have started to complain. Now, I'm not saying, because I know there are vendors here who are probably like, oh no, what is she saying right now? I'm not saying that you should be, like constantly robocalling them, but tell them when something doesn't work for you, please. Because our organization cannot be the voice of 250,000 labs, because we don't buy anything. So as much as we can say this matters, at the end of the day, it's what you do and what you say that really matters. So talk to people about what you want to see. And then look for the ACT label. So what is the ACT label? The ACT label is an eco-nutrition label for laboratory products. And I'm just going to briefly introduce it here because Scott is going to spend more time talking about it. But what this is a way for you to understand the environmental impact of a product and its packaging. It looks at the manufacturing, the use, and the end of life of a product and its packaging and gives you, just like a nutrition label, a score for each one of the product attributes. So at the end of the day, if you're faced with two products and you actually want to know which one is more sustainable, you can just look at the label and make a choice that way. So I want to leave you with this quote that I really like from Jane Goodall, which says, you cannot get through a single day without having an impact on the world around you. And this is true not only obviously in the lab, but everything you do, everything, it makes a difference. And you get to decide what kind of difference you want to make. So you're all here because you want to do something about what you're seeing in terms of trash and what you're discarding in the lab. So I really hope that this sets the stage and that the rest of this evening, you're inspired to actually do something about it. So with that, thank you.